Sensation and Perception, Chapter 2, Part 1, pages 31 to 35. The first steps in vision, from light to the neural signals. Section 1, A Little Light Physics. So, to begin, light is a form of electromagnetic radiation, vibrations of electronically charged material. They are in two forms, a wave and photons. The wave looks like a continuous line that goes up and down, and photons are like dots that get closer together in density and further apart. Waves are for the purpose of motion in space, and photons are for the purpose of absorption. Electromagnetic radiation is a spectrum, and it begins with only a small percentage, and then, for example, it goes to gamma rays, to visible light, to radio rays, and much more. So, the example in the book starts with a star's light going into the eyeball. So first, there is light that goes a straight line in the speed of light through the atmosphere. The photons are absorbed, which means they take up, with no transmission, by dust, water, and etc. Some are scattered, which means they're dispersed in an irregular fashion, also known as diffraction by particles. Making it through the atmosphere, it hits the surface of an object, a light-covered surface, light mostly reflected, redirection, usually back to its origin. The light appears from the reflection, some absorbed, neither reflected or absorbed. It is transmitted, which means through the surface. And then, if it's through a window, for example, the light in the air to the glass is bent, called refraction. Another refraction is when it hits water. Section 2 is the eyes that capture the light. Eyes can see not only light, but also images and recognize objects. The physiological mechanism of the human eye begins with the cornea. It's the first tissue that the lights hit. It's a window transparent, which means light can pass through with no interruption. There's no blood vessels, and it has a transparent nerve endings that makes you blink or produce tears. Then there's the aqueous humor, fluid derived from blood in a space behind the cornea. It supplies oxygen and nutrients, and it removes waste from the cornea and lens. The lens is no blood supply, and its shape is like a pebble almost, and it is controlled by a ciliary muscle. The pupil is right before the lens. It's a dark circular opening in the center of the iris. The iris is the color part of your eye, which is brown, blue, hazel, a mixture, and it has a muscle that contracts and also opens up. Then there's a vitreous humor, and that's between the lens and the retina. Light refracted for the fourth final time, and 80% of volume of the eye is a vitreous humor. Then in the back of the eye is the retina, a light-sensing membrane in the back, and it contains rods and cones, and that is what creates the image. And then it goes to the brain. A subsection is called focusing light on the retina. So to see good for optic components, most perfectly mastered is the length of your eyeball. Tropia is the perfect condition, no error in the shape of your eyeball. Diopter, a diopter is the unit of measurement of the optic power of the lens. It's a reciprocal focal length. For example, 2 diopter is a half a meter. Myopia is nearsightedness. That is when there is a problem with looking at distant objects, and it's corrected by negative lenses. There's hyperopia, which is farsightedness. Objects near are unclear, and positive lenses correct that. Astigmatism is when the cornea is not spherical, and then there is accommodation in which the eye changes focus contracting through the ciliary muscle. The lens is attracted to the ciliary muscle, and that's to close and to open. Accommodation allows up to 15 diopters. But throughout the years, you lose about 1 diopter per 5 years until you're 30, and then it exponentially starts to get worse. Presbyopia is old sight, which means it's the age-related loss of accommodation. And then there's also cataracts, which is the condition of opacity and the lens. And there's congenital cataracts.